Let's consider the graph f of x of some random cubic function. Right, so let's say that its graph looks something like this. And there's a few features that I'd like you to notice about the function. The first is if we were to think about the tangents, the slopes of the tangents lines, here their slopes would be positive because the function is increasing. Somewhere in here there would be a horizontal tangent. Then there's a section where the slopes would be negative and the function is decreasing. Another horizontal tangent and the slopes would be positive. One other feature I'd like you to notice is that this portion of the graph is concave. That's terrible. Is concave down. And this portion of the graph is concave up. And somewhere about here is where it changes from concave down to concave up. Now, since this is the graph of a cubic, it should follow that its derivative would be some form of a quadratic. It looks something like this. Notice that some things to notice would include that if we had this on some type of coordinate plane, say it looks like that, here's the portion of the derivative that's positive. Here's where the derivative equals 0. This section is where the derivative is negative. It's 0 again. It's positive. Notice that if we were to consider the slopes of the tangent lines of the derivative, that from here to this point right here, the tangent lines would all be negative. Here, the tangent line of the derivative would be 0. And then from this point, from that same point on, the slopes of the tangent lines would be positive. And notice how that would relate to the concavity of the original function. It should follow, since this derivative is a quadratic, that its derivative would be linear. And if we were to graph it, it might look something like this. And notice that here the function, the second derivative is negative. At this point, the second derivative has a value of 0, and then it continues on to positive. And so, if this made sense, you can see direct relationships between the function, its derivative, and its second derivative related to the function increasing, decreasing, whether the function is concave up or concave down. You can see all of these things by considering the derivatives. And so this would give you maybe an intuitive sense of the the tests that we talked about being the first derivative test and the second derivative test.